All right, so I'm recording my lecture, and at the end of this class, I'm gonna put it on YouTube, and you're gonna see it tonight or tomorrow. All right. So I'm gonna put the link to the YouTube video on Canvas as well. So today we have these donuts. So it's in a bad corner, but from Thursday I'm gonna put it here, so it's better. All right, so let us start our first lecture. All right, so the first one is 1.1, Introduction to OE. So example. All right. So in order to understand differential equation, we have to understand where it comes from, right? So in general, differential equations comes from real-world applications. For instance, you can have an example from economy, an example from physics, from chemistry, from engineering, from artificial intelligence. I mean, everything in this world can be modelized at differential equation, a system of differential equation. And one of the examples is the following. So suppose that population of Washington, D.C. grows with the rate 2% per year, and there is net migration into the city of 15,000 people per year. So write the equation. All right. So this is one situation when you need a differential equation, right? So I'm gonna study the population of Washington, D.C. And I know that this is growing like 2% per year, right, by death and birth. And then there's an immigration of people into Washington, D.C. And every year you're gonna have 15,000 more people, right? So what is the equation for this very common situation? Yes?
So it would be if P was your population, the equation for the rate would be 0.02 times the variable for the year plus 15,000.
Wow, excellent. Can you hand the back of the paper, please?
Yes.
Thank you. Right, so this is excellent. So you call the population it's gonna be P, T, right? So T is the time, is the time variable. Of course, it is the year. For instance, PT is 1 people. All right. So I'm gonna call the population by a new unknown, which is PT. So of course I have to have the time because I have to know the population at this year or next year or 2000 or 2005. So t is the time variable, which is the year. All right, and p is the number of people in Washington D.C. right, which is the number of population, the number of people. In D.C. right? So for instance, P of 2019 is this one. Right? So T in this case is 2019. So I explain again. So I'm gonna need P, which indicates the population. So for instance, P can be 15 million. All right. So P is the number of people inside DC. But I'm gonna need a variable which is the time. And so the time can be 2019. So I can say that in the year 2019, the population is 15 million people. All right. So every year, so you're gonna grow population growth is 2%, which means that you have 0.2 pt. All right. All right. So the population growth is 2%, which means that at this time, at this year, the growth is 0.2 pt. Right. And so you also have an immigration rate, 15,000, which means that in total you're going to have 0.2 pt plus 15,000. All right, so this is the growth by birth and death. All right, so I explain again. So every year by birth and death, you have 0.2 pt more people. But you also have, yes?
Should it be 0.02?
This is, yes, thank you. 0.02. This is excellent remark. Can you sign at the back of the paper, please? Did you sign?
Yes, thank you. I'm in the front there, Elena.
Yes, but you, I mean, you have to
Oh,
resign
sorry,
it.
thank you. Yes, thank you.
So the other one is to check attendance. and
Yes,
this one.
I'll cross out the other one. Thank you. Sorry. Thank you.
All right, so I make a mistake. 2% is 0.02. So the growth by birth and death, is 0.02 p, and the number of people who are coming into the city every year is 15,000. So the total rate will be 0.02 times pt plus 15,000. All right. But we need, so this is just a formula. I need an equation, right? So what is the rate? If I give you a pt, so what is the rate of growth for pt? Anyone else? Yes?
Wouldn't you just want to take the derivative of that growth?
Yes. No, not this growth. This is the given growth, right? So, the good one is d over dt of pt, right? So given pt, the growth can be computed. Yes, right? So you give a function, and the growth will be the derivative in time of p. Right? Can you sign the back of the paper, please? So what we have now is you have one growth, right? Which is the derivative in time of pt, and the next one is 0.0 pt plus 15,000, right? So this is the first This is also a growth. And this is also a growth. All right, so what we do is we make this to be equal to this one. Right, so you have d over dt of pt is equal to 0.02 pt plus 15,000. All right, so this is a differential equation. So this is a differential equation. All right, it's clear? So I explain again. So to modelize the population in DC, what you need is a function pt, and this function is a function of time because you want to see the evolution of the population in terms of time, in terms of year, right? So this is going to be p of t. So every year, the birth and death will give you 0.02 pt, and the number of people who are coming into the city will be 15,000. So in general, you're going to have 0.02 pt plus 15,000. So this is the growth rate of the population every year. But the rate going to be also the derivative in time of pt, right? So you're going to have two rates, this one and this one. You make them equal, you have d derivative in time of pt is 0.02 of pt plus 15,000. And this is giving you an equation. This is a differential equation. So, so in this differential equation, all right, so t is the variable, and p is the function of t. Which is the population. All right? It's clear? Questions? So what we are doing here is the so-called modeling. This, what we are doing. It's just the modeling of a real-world situation into a model, which is an equation. All right. So what we have just done is to model the real-world situation, which is the population of the growth of the population of DC every year. So this is the real-world situation. This is the growth of the population of DC. All right. So we're going to modelize this this real-world situation into a model. So normally a model should be an equation or a system of equations, right? So if you solve this equation, all right, you're gonna know PT. So if we solve the equation, we have PT. All right, so you're gonna know the population of the Washington DC every year. And now, so here I call this a differential equation. So why do I call this equation a differential equation? Anyone else? Yes?
And the derivative in the equation?
Excellent. Can you sign the back of the paper, please? So there's a derivative inside the equation. So this is why I call it a differential equation. All right. So there are two types of equation now. So you have algebraic equation. All right. So you're gonna have x squared plus 2x plus minus 5 is 0. So this is an algebraic equation because you don't have derivative. What you have to do is to solve for x. All right, or x minus 5 to be 0. In this case, you know that x is 5. So what you have to solve in an algebraic equation is a number. So when you solve this equation, when we solve them, the result are numbers. All right, so this is what we used to. So we solve an algebraic equation, what we get is a number, right? But for differential equation, we have derivative, right? So for instance, for this one, we have derivative of p is 0.02p plus 15,000. When we solve them, the result our function. All right? So in a differential equation, you have derivatives. And when you solve differential equation, what you get is a function, not numbers. All right? So this is the basic difference between an algebraic equation and a differential equation. It's clear? Right. So now this is one equation. So you can also have a system of equation. All right? So system of equation. System of differential equation. So one example is the following. So you have dt over d f prime of t is equal to 1/2 of 2g of g over 100 minus 3 f over 100 and g prime of t is ft plus 3. So this is an example of a system of differential equation. So what we have to do is to find two functions f and g. So they are function of t, such that when you take the derivative in time of f, you're going to get 1/2 plus gt over 100 minus 3 ft over 100. All right? And you take the derivative in time of g, you're going to have ft plus u, right? So this is a system of differential equation. So what you get at the end are functions, right? So f and g are functions. All right. So if you solve a system of algebraic equation, what should you get? Yes? Numbers. Yes. Can you sign at the back? The paper, please. So if you have a system of differential equation, the solutions are functions, right? When you have a system of algebraic equations, what you get at the end are numbers. Right? So this is basically you have to see the difference between differential equation and the other type of equation. Questions? Good. Right. So let us move to 1.2. First order differential equation. So now we're going to learn how to determine the orders of differential equations. Right? So now I have two equations. I have f prime is equal to f, which is a function of t. All right? And f prime is equal to ft squared. This is another function equation. I call the first one 1, 2, and 3. I have f. So let's take it prime. Second of t is ft plus ft squared. So you have f second of t is ft plus f prime of t. All right, so I have 4 equations. I'm gonna try to determine the orders of those equations. All right, so I'm gonna call this. I'm gonna say that this is of order 1. I'm gonna say that this is of order 2, order 1, and this is of order 1. And I call order 2. And I'm going to say that this is of order 2. So can you guess why I can say that these two are of order 1 and these two are of order 2?
Because the highest order of derivative in the equation is 1 for equations 1 and 2, and for the highest derivative is 2.
Thank you. Yes, can you sign the back of the paper, please? All right, so this is a very excellent answer, right? So if you look into a differential equation, you look into the highest order of the derivative. That will be the order of the differential equation. So in this case, you have the first order derivative of f is equal to f, which means that the order of this equation is 1. For the second one, so you have the first order derivative of f is f squared. So this is going to be the order of your differential equation because you have first order derivative. All right? So in the third case, you have f second. The second derivative of f is equal to f plus f squared, right? So in this case, you have 1 second derivative. So I'm going to say that this is of order 2, right? So in the last one, you're going to have second order derivative, first order derivative, and the function f. So here you have 2 derivatives. But the order of the equation is 2 because you're going to take the highest order of the derivative, right? So the highest order of the derivative will give us the order of the differential equation. All right. So if you look into a differential equation, you look for the highest order of the derivative, you're going to get the order of that equation. It's clear? Questions? Now, let us try to solve one example, and then you're going to know how to solve the first order differential equation. All right, so example. You're going to have to show that x is equal to 3 e to the t squared. Is a solution of the following differential equation. Dx over dt is going to be 2tx. All right? All right, so now I'm going to give you a differential equation of this type. All right. So I'm gonna have dx over dt of 2t xt. So this is the full form, but I can give it. I can write it in a shorter form, which is dx over dt is 2tx. All right. So I can sometimes I can forget the t dependence, but we know that x is a function of t. All right. So you have to be careful because x is a function of t. A function of t. All right, and t is the variable. T is the variable. All right, so I explain again. Now I have an equation. Dx over dt is equal to 2t of xt. Right, so x is a function of t. X is not a number. Now, because we are solving differential equation, right? So sometimes, if for convenience, we can forget about this t. So I can write it like dx over dt is 2tx. But you have to keep in mind that x is a function of t. This is not just a number, it's just a function of t. And t is the variable. This is why here you have dt, and here you have 2t, right? It's clear? So from now on, I'm gonna forget about this t dependence here. And now what I want to show is that I'm gonna take this function xt is 3 times exponential of t squared. I'm gonna plug that into this equation, and I'm gonna have equality, right? It's clear? So when I have equality, I'm gonna say that this is a solution of this equation. All right, so what we're gonna do, so our plan is the following. We will take the function xt, which is equal to 3et squared. All right, we will compute dx over dt. All right, so we will compute 2t xt, and we will see that the x over dt is going to be 2tx. All right, questions? So I explain again. So I'm going to take this function, xt is 3et squared. The first step I'm going to do is I'm going to compute the derivative in terms of xt. The second step I'm going to compute 2t xt. And I'm going to see that the first result and the second result, they're equal. So when I see that the first result and the second result are equal, I'm going to say that this is a solution. This function is a solution of this differential equation. It's clear? So let us do it. So step number 1, I have this function. I'm gonna take derivative in terms of e 3 times et squared. All right. So how can I compute the derivative of this function? Anyone else? Yes?
Use the chain rule?
Chain rule. Yes, excellent. Can you sign the back number paper, please? So I'm going to use the chain rule, right? So I'm going to use the derivative in terms of f of g t will be f prime of gt times g prime of t, right? So this is basically the chain rule. This is the chain rule. So you have to take the derivative in terms of f of gt. So what you do is you compute g prime, f prime of gt times g prime of t. In this case, f of gt will be 3 times et squared. All right, so f will be 3 times g, f of 3 times g, and g will be t squared. Right? So you're going to use chain rule. So you have to identify the two functions. F of gt will be 3 et squared, f will be 3 of e to the g, and g will be t squared. Right? So you're going to do the chain rule, and what you have is the following. So you have d, dt of 3 et squared will be 3e to the t squared times 2t. And this is going to give you 6et squared. Right? Because the derivative, so f prime will give you 3e to the g, and g prime will give you 2t. All right? Yes?
Would it be 6t e to t squared?
This is, right? So first I have 3 dt squared. And the second one, I'm going to take the derivative of t squared. I'm going to have 2t, so I have 6 et squared. T. Thank you. Can you say at the back of the paper, please? So I explain again. So here in this case, I'm going to use chain rule for the function f, which is 3 e to the g. Derivative of function f will be 3 e to the g, and the function g will be t squared. So the derivative of this function is 2t. Right? So then you put the two things together. You have 3 et squared, which is the derivative of f, 2t, which is the derivative of t squared. Put the two together, you have 6 et squared t. Right? Questions? Now, second step. So what I have to do is to compute 2t of x. All right, so when I compute 2t of x, this is quite straightforward because I have 2t times 3 times et squared. All right, so this is going to be 6t et squared. All right? The second step, I'm going to compute 2tx. 2tx will give you 2t times 3 et squared. So this is going to give you 6t et squared. So which means that this one is equal to this one, right? So step 3. d over dt of 3 et squared is 2t 3 et squared, which means that d over dt of x is 2tx. All right? So in the last step, I'm going to compare this guy and this guy, and I see that they are equal. So I'm going to say that dx over dt is equal to 2tx. So we say that x is equal to e to the t squared 3 times is a solution of the differential equation. dx over dt is equal to 2tx. All right? Questions? It's clear? So, to summarize, what we have is the following. I have a function, xt, which is of the form e t squared. All right? So I say that this function is a solution of the differential equation, dx over dt is equal to 2xt. Right? So I recall you that, okay, I write the equation under this form, but the true meaning of this is dx over dt of xt is 2txt. Right? So this is the true form, but to be more convenient, I'm going to drop the t, but you have to understand that x is a function of t in this expression. All right, so I'm going to say that this function, 3et squared, is the solution of this equation if when I compute the derivative in time of this function, I get this number, and when I compute 2tx, I get this number, and these two numbers have to be equal. Right? Questions? It's clear? So all of this, I wrote all of this in my lecture note, and I'm gonna put it on Canvas after the class. All right. So in general, we will try to solve first order differential equations of the form dx over dt is equal to ftx. All right? So in general, we're going to try to solve first order differential equation of this form. So in this case, in this example, in the previous example, dx over dt is 2tx, then ftx has to be equal to 2tx. All right? So in general, I'm going to denote the right hand side by a function ftx, right? So I'm going to try to solve differential equation of the form dx over dt is equal to ftx. So in the previous example, this example that we have here, I have dx over dt is equal to 2tx. So the function ftx will be 2 times of tx, right? It's clear? Questions? All right, so we're going to try to solve our first order differential equation. So example. Solve the equation. You have dx over dt of x is t squared. All right? All right, in this case, you have to find finding a function x such that x prime is equal to t squared. All right, so in this case, we try to solve a very simple differential equation. You have dx over dt is equal to t squared. All right, so in other words, you have to find a function x such that the derivative of x is t squared, right? So any ideas how to solve? Yes?
Integral.
Take the integral, right? So can you stand that like that? So in this case, you have x prime is t squared, right? So which means that x is the antiderivative of t squared, right? So since x prime is equal to t squared, so x is the antiderivative of t squared. All right? So in other words, you have what? You have xt is the antiderivative of t squared. All right? And what is the antiderivative of t squared? Yes?
1 over 3 t cubed plus e.
Yes. Can you say it? So this is t cubed over 3. All right, so this is a very simple example. So in this case, you have derivative in terms of x is t squared. So this can be understood as x prime is t squared. In other words, x should be the antiderivative of t squared. So this is calculus. So what you find is that the antiderivative of t squared should be t cubed over 3 plus c. All right, so I have to write this as s squared ds. All right. Questions? All right, so now, in general, if we want to solve the x over dt of x is equal to ft. So ft is any function, all right? So what you do, so ft is any function. Ft can be t squared, t cubed, all right? So what you do is you just take, we only need to take the integral on both sides. The integral on both sides. All right? So what we have is the following. So you have xt is going to be the integral from minus infinity to t of ft plus a constant c. Right? And this is the formula of the solution. Right? So here I'm going to have to put minus infinity to t and I put a c. All right, so there are two formulations that I just wrote, so but I prefer this one. This is definite integral in which you have the two limits. All right, so if you prefer, you can forget about the two limits, and this is definite. This is indefinite because you no. So let me write here. So this is the s is the indefinite interval. That just denotes the antiderivative, all right? And to be more precise, I'm gonna have to put two limit interval. All right? So both are good. So the first one is an indefinite interval, which denotes the antiderivative of the function t squared. So in this notation, you don't have the two limits. All right? In the second one, you put the two limits, and this is the so-called definite intervals, but this is going to be fine. It's just notation. As far as you understand what is written there, then it's fine. You can use both in exams. So I explain again. In general, you have dx over dt is equal to ft. So f is a function of t, not of x, right? So f can be t squared, t cubed, anything. So in order to solve this one, you need to take the antiderivative of the right-hand side. So you have xt is the integral from minus infinity to t of ft plus c, right? Fs plus c, sorry, and f ds. Questions? So far, so good? It's clear? Right, so if there is no questions, so now I'm going to have another example we need to solve. Example. Dx over dt e to power minus t squared. So in this case, we have a very similar situation in which you have the derivative in terms of x is equal to e to power minus t squared, right? So how do we solve it? Yes?
Separate the variables and then take the integral of both sides of the equation.
That is excellent, but this is going to be better if you have, I mean, that is a very good strategy, but it's going to work better if you have an x here, right? But now let us try to focus only on this case, right? So how, but anyway, could you sign the back of the paper, please? So how can I solve this equation? So what is the function f in this case? Can you, who said that? Yes, can you sign at the back of the paper, please? So you have the function f, which is e to the power minus t squared. All right? So again, this formula can be applied, right? So what you have is xt is going to be the integral from minus infinity to t of ms ds, all right? Plus a constant c. And this is going to give you minus infinity to e to power minus s squared ds plus c, all right? All right? So I explain again. In this case, you have to solve an equation. Dx over dt is e to power minus t squared, right? Which means that you have to find the antiderivative of t squared. All right? So the formula there can be applied. So ft is going to be e to power minus t squared. So xt will be the integral from minus infinity to t of fs ds plus some constant c. So I'm going to replace f to be e to power minus s squared. So this is going to be minus infinity to t integral of e to power minus s squared ds plus c. And what is the explicit solution for this? So, right, so in the previous case, this is quite easy, right? So you have an integral from minus infinity to t of s squared ds, and you know that this is s cubed over 3. But in this case, it's different because you have exponential minus s squared. So the previous case, you can take the antiderivative of t squared easily because the antiderivative of a polynomial has a formula, right? But in this case, you have exponential. So how can you take the antiderivative?
Could you do a u substitution?
How do you substitute?
Like make u is equal to negative s squared and then solve from there.
That's a good. Can you sign the back of the paper, please? Yes, that is a good strategy. But if you have a sinus s here, that works. But in this case, it doesn't work. So this function do not have an explicit antiderivative form. So I'm gonna leave it there, right? So in this case, the antiderivative of exponential minus s squared ds does not have an explicit form. All right, so we're gonna keep it there, right? So we only need to write to leave it as minus infinity to t of e and minus s squared ds. All right. So for polynomial function, we can take antiderivative easily, but for exponential one, in general, you don't have the form for that. So you just leave it there, yes?
Yes. This is, we started the problem, the variable was in terms of t. By the end of the problem, we switched it to the equation in terms of s. Does that matter at all?
Yes, it's a very good question. Can you sign the back of the paper, please? So why do I switch it to s here? Very good questions. Yes?
Because you made it a definite integral,
Right.
When you have to put P into the definite interval, so you're using S as a different variable.
Excellent. Can you sign the back of the paper, please? So, yes. So in this case, you have what? You have minus infinity to t of e to the power minus s squared ds, right? In this case, s is the variable that you use to do the integration. It's going to be disappeared, right? So this is a function of t. This is a function of t only, because s is the variable that you use to integrate out. All right, so s will be disappeared. Right, so when you integrate this variable, this function, what you get is a function of t. Similarly, in the previous situation, you have what? The integral from minus infinity to t of s squared ds. This is going to give you t cubed over 3. Right, so there is no s, and there is no s in the final form. Right, so s is a variable that you use to integrate, and that is going to be disappear after you integrate out. Okay, so in this case, you're gonna get t cubed over 3. All right, so in this formula, s is not here. What you see is just t. So this is function of t. You say, can you? Yeah. Okay. So other questions? It's clear, right? So we still have like 7 minutes, right? So this is a little bit fast, right? All right. All right. So now let us try to make another constraint on this equation. So you have solve dx over dt is e to the power minus t squared with the constraint x3 is equal to 7. All right. So now suppose that I put something there. So I want to solve this equation, but I also give you one condition, that x3 has to be 7, right? So this is the new condition. So I put a new condition, which is x3 is equal to 7, right? And this is, and I still have to solve this equation, but with an extra condition. So how do I solve it? Yes?
You'll solve it the same way you did the last one, but then once you take the integral, you have to solve for what c is.
Right, excellent.
Setting x to 3.
Excellent. Can you say at the mic, please? So yes, this is an excellent answer, right? So you have to solve for this c. So let us try to do it. So using, again, this formula, you're going to have xt is integral from minus infinity to t of e to the power minus s squared ds plus c. This is what we have from the previous exercise. The previous exercise. All right? So from the previous exercise, you know that xt has to be integral from minus infinity to t of e to the power minus s squared ds plus c, right? So now you have to use this condition. So using the condition, you have x3 is going to be integral from minus infinity to 3 of e to the power minus s plus c. All right? So now you use the condition. You know that x at 3 is equal to 7, right? But you also know that x at 3 will give you the integral from minus infinity to 3 of exponential minus s squared ds plus the constant c. So this, again, this is a number. Since it is an integral, with explicit limit. All right? Yes?
So then C would be 7 minus the integral?
Yes. So can you sign the back of the paper, please? So I'm gonna use the initial condition. I'm gonna use this new condition. I'm gonna have 7 is x3, and x3 is this interval, so plus c. So this interval is an explicit number because I have explicit limits, right? So which means that c is 7 minus this interval. So I'm gonna have c is going to be 7 minus integral from minus infinity to 3 of e to power minus s squared ds. All right? So now with this new condition, what we can do is to solve explicitly the constant c. I'm gonna plug this c back into the solution. I'm gonna have xt is going to be integral from minus infinity to t of e to power minus s squared ds plus 7 minus integral from minus infinity to 3 e to power minus s squared ds. All right? So now I'm gonna plug this new constant into the form here, right? So I'm gonna plug this here and I get this formula. All right? So now I'm gonna group the first and the last integral, and I'm gonna have integral from 3 to t e to power minus s squared ds plus 7. Right? So I explain again. So I'm gonna use this new condition. I plug it back. I find c to be this one. So I plug this c back to the form xt. I'm gonna have the integral from minus infinity to t minus the integral from minus infinity to 3. So I can simplify that into an integral from 3 to t. And I'm gonna put that number 7 right here. All right? So, 1 second. So this new condition is going to be called the initial condition. Yes? This one, from this to this. This one to this one. All right, so after this step, I'm gonna find c to be 7 minus this one. Right? So I'm gonna have 7 minus the integral from minus infinity to 3 of e to power minus ds, and this is c. Right? So I'm gonna plug this c into the c that I have here. All right? So I plug this c into this c, and I get this formula, which is the replacement of c by the new quantity that I just found. All right? And I get this one, and I plug it back, and I subtract the 2 integral, I get this one. So this new condition is called the initial condition, right? So the initial condition is a condition that you put onto one explicit value of the function, and then, for instance, in this case, you put the condition 7 onto the explicit value of t to be equal to 3 of the function x. So we, yes?
I'm sorry, I just had one question about the syllabus that I forgot. Will there be readings posted on Canvas?
Sorry?
Will there be readings of the textbook posted on Canvas?
So I'm gonna put this on Canvas.
Okay,
That's gonna be fine.
okay, thank
So,
you.
but the homework will be from the book.
Thank you, okay.
Yes. Other questions? Yes?
Could you explain how you combine the intervals?
Right. So here I have an interval from minus infinity to t. Here I have an interval from minus infinity to 3. Right? So what I use is the following. So I have a minus infinity to t of something minus infinity to 3 of something. And this is gonna be 3 to t. Alright? So you integrate from minus infinity to t, and here you subtract the integral from minus infinity to 3. So what you get is the integral from 3 to t. That's clear? So the formula that I have is the following. This is fs ds. This is fs ds ds. So you have an integral from minus infinity to t of this function fs minus the interval from minus infinity to 3 of this function fs, and I'm gonna get the interval from 3 to t of fs, yes. Okay. Other questions? It's fine.